Alright guys, so today we're actually working on section 2. So this is 4.2, and the title of 4.2 is Trig Functions and the Unit Circle. Okay, so 4.2, Trig Functions and the Unit Circle. Alright, we spent a good amount of time now. So if you're watching the video, you didn't get to do the activity. We spent a few minutes filling this information out. You're going to find a copy of this online, so if you're watching this video, just print this out. We're going to be using this today a lot, so I want you to have it next to you. So here's what we know. We know that the unit circle is given by what equation? So the unit circle is given by x squared plus y squared equals 1. So I'm just going to draw a rough sketch here on the side. Here's my x-axis, here's my y-axis, and there's my beautiful unit circle. Okay? Now, during the activity, you use right triangles to figure out the coordinates of different angles. Agreed? So, for our notes purposes, let's pretend that I have a point here, and that I'm trying to figure out what that point is. Well, using triangles, I can figure out what that point is, because we know that the unit circle has a radius of 1, correct? And if I try to figure out what x and y value this is, from the origin I can travel x units, right? And then I can travel y units, and that would be a right triangle, correct? By creating this triangle, then I have created an angle here, and we're going to call it angle theta. Okay? Are you guys with me? We can now use this to find trig values. So we can use the unit circle to find trigonometric values. And here's what I mean by that. Alright, very first lesson of this unit, we talked about all 6 trig ratios, which are sine, cosine, tangent, cotangent, secant, and cosecant. And the very first time I mentioned that, most of you guys said SOHCAHTOA, right? Well, we're going to use SOHCAHTOA with the triangle that I have in front of us. So here's the trig ratios. And the unit circle. Alright, so if we use this unit circle, let's talk about sine of theta. Using the triangle that you have there, can you tell me what the sine of theta would be? Well, sine is opposite over hypotenuse, and here's opposite, so it would be y over, which simplifies to be y. Cool. Can you tell me what cosine would be? Adjacent over hypotenuse, so x. Agreed? Alright, I'm going to take a moment and pause there, because these are really, in my opinion, 2 of the most important trig ratios. You don't have to flip back, but I want you to look at the screen. You just found out the sine of an angle is y, and cosine of an angle is x. So why did we create this entire thing? Well, check this out. Let's look at altogether at angle 30 degrees. We know that this is the x and this is the y, correct? And technically 30 degrees goes from there to there, that's 30 degrees, correct? I could then ask you, and without you having to draw a triangle, I could say, what is the cosine of 30 degrees? You just learned that cosine is what? the x, so what is the cosine of 30 degrees? Root 3 over 2. And then I could ask you, what is the sine of 30 degrees? And you discover the sine is y, so the sine of 30 degrees is 1/2. And that is how we're going to be using the unit circle to figure out trig ratios. Okay? That's in summary what we're going to be doing today. However, we know that there was more than just sine and cosine. Agreed? So unfortunately for you, the unit circle only gives you sine and cosine. But you can use the unit circle to figure out the rest. And here's what I mean. Tangent of theta. Tangent of theta, using that triangle, would be what over what? Y over x. And I'm going to improve that for you. Because now I know that y is the same thing as saying sine. And I know that x is the same thing as saying cosine. So I just found out that tangent is the same thing as saying sine divided by cosine. So even though I don't have tangent on my unit circle, I have sine and cosine, and I can use it to figure out tangent. Do you guys get where I'm going with this? Okay. What would be cotangent of theta? Well, cotangent would be the reciprocal of this, so it would be x over y, which is the same thing as saying what over what? Cosine of theta over sine of theta. Alright, so good so far. So far so good, I said it backwards. Anyways. Alright, so now we have two more ratios. We have secant and we have cosecant. Which one is the reciprocal of sine? So cosecant is the reciprocal of sine. So if sine was y over 1, that means that cosecant is saying 1 over sine of theta. Lastly, we have secant. And we know that it's the reciprocal of cosine, so it's 1 over x. And we can further improve it by saying 1 over cosine x. I'm sorry. Yeah. I should be using thetas, but whatever. Questions? We have now taken SOHCAHTOA and transformed it into more mathematical approach to it. That's all we did. It's still SOHCAHTOA, do you guys agree? It's all we did, but now we actually got rid of those nice little abbreviations and we substituted actual math terminology into it. Okay? You're going to need those. And here's what we're going to do today. You're going to be able to apply this to any angle that I give to you. Okay? So, let's start out with an example. I can say find all 6 trig ratios of theta equals, I don't know, 5 pi over 6. Now, today, you don't know your unit circle yet, so you're going to be using it to answer these questions. But eventually, you're going to be able to answer these questions without using your unit circle or having it next to you. You're going to have it memorized. So here's what we're going to do. 5 pi over 6 is located in quadrant 2, so I'm going to use that angle to help me out. So here's my unit circle. Just by looking at my unit circle, you should be able to tell me the sine and the cosine. So what's the sine of 5 pi over 6? Remember, sine is y. So 5 pi over 6 is located here. So sine has to therefore be 1/2. What would the cosine be? Negative square root of 3 over 2. Once I figure those out, then I can kind of put this to the side. I don't really need my unit circle anymore. I can come up with the rest just by using sine and cosine. Agreed? Alright. Tangent is what divided by what? Sine over cosine, or yes, I agree, y over x. Well, don't you have the sine? And don't you have the cosine? Right? And from there, can you manipulate this algebraically? leave the top fraction alone, switch to multiplication, and do the reciprocal, so that becomes negative 2 over root 3. Cool? You guys all with me? Alright, so that cancels out, leaving you with negative 1 over root 3. Which technically you are correct, we just got to write it in simplified form, right? We don't want radicals on the denominator. So here's what we know so far. Tangent of theta equals to negative 1 over the square root of 3, correct? So how am I going to rationalize this? Multiply both top and bottom by the square root of 3. Okay? So then this becomes negative root 3 over 3. Alright, so we know the sine, we know the cosine, and we know the tangent. Notice how I typically like to find those 3 first, because finding the next 3 becomes. Okay, what's the reciprocal of sine? Cosecant. So if sine was 1/2, that means cosecant is 2. Okay, reciprocal of cosine is secant. So if cosine is square root of 3 over 2, that means secant is 2 over square root of 3. And I'm sorry, I forgot there's a negative there. So negative 2 over root 3, right? And unfortunately, you would have to do some math here. So I'm going to multiply by root 3 by root 3. So this becomes negative 2 root 3 over 3. Last one, cotangent. Well, cotangent, remember how earlier we had found out that tangent was negative 1 over root 3? And then we'd rationalize that? Well, rather than using that, so I don't have to do math, I'm going to use this. Because if I do the reciprocal of that, what does it become? And I have to do no math. Right? So here's what we found out. The sine of 5 pi over 6 is 1/2. The cosine of 5 pi over 6 is negative root 3 over 2. The tangent of 5 pi over 6 is negative root 3 over 3. The cosecant of 5 pi over 6 is 2. The secant of 5 pi over 6 is negative 2 root 3 over 3. And the cotangent of 5 pi over 6 is negative root 3. Cool? All just from one unit circle. Alright. Can you guys replicate what I did here? So here's what I want you to do. I want you to find all 6 trig ratios of the following. Theta equals 4 pi over 3. Okay, 4 pi over 3. So find all 6 trigonometric ratios of theta. Alright, if you're watching the video, please check your answers. And then I have one more for you. This time, theta equals negative 7 pi over 6. Okay, before you start working on that, let's make sure that we all know how this could work. We all know how negative angles work. Agreed? The initial side is at the positive x-axis and it rotates clockwise. So even though I have my unit circle, I don't have any negative angles written on it, but you can still use it to find negative angles. You're just gonna have to go backwards. So notice how you were going pi over 6, pi over 4, pi over 3 on this direction. So when you go in the other direction, that means you're gonna have negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 3 pi over 4, negative 5 pi over 6, negative pi. So that means that negative, what I asked for, negative 7 pi over 6 would be located at here. So that means negative 7 pi over 6 is what with 5 pi over 6? Coterminal. Good. So now that you know where it's located, could you figure out all the trig ratios? Okay? I don't want you to actually do it for time's sake. I just wanted to show you how the negative angles work. Because I'm sure you can apply everything we did. Yes?
So it's the same, like, negative 3 over 2.
It'd still be the same coordinates.
Okay.
Yes, same exact coordinates, so you can apply all the trig ratios. But that's how negative angles would work. Yes? Alright, so then move on to something new, sort of. I want you to find the following trig ratios, okay? I want you to find out what sine of 5 pi over 7 is. I want you to find out what cosecant of 2, cotangent of 36 degrees, tangent of 90 degrees, secant of 1.5, sine of 2 pi over 3, and last but not least, I want you to find the cosine of negative 380 degrees. So I have how many? 1, 2, 3, 4, 5, 6, 7 different ratios that I need you to find. Okay, here's my question to you. If we look at sine of 5 pi over 7, suggestions. Well, what we've been doing is you would first look at your unit circle, right? Alright, so 5 pi over 7, 5 pi over 7, I don't have anything with 7s in here. So I can't use my unit circle. Now, here's my point with this. The unit circle talks about very special types of angles. Is that the only angles that exist? So that means that you can't answer all the questions using the unit circle. So you will have a calculator for this, so take out your calculator. You should be able to figure all this out with your calculator. Here is what's going to become very, very important. Your mode. We talked about mode on our first lesson of trig. If you go back to your calculator and you go to mode, remember that there is radian and degree. You're going to have to switch back and forth depending on what you're working with. The very first one you have to be in radians, so I'm good. If you're not in radians, then switch to radian. And I'm going to get out of there, and all I got to do is simply type it. Sine of 5 pi over 7. And we always round to 3 decimal spots in this class, so 0.782. So approximately 0.782. Cool? Alright. I'm going to do one more with you and then I'll let you try the rest on your own. Cosecant of 2. Am I in radians or degrees? I heard both. Do I have a symbol for degree? Remember, if you know in, so this is radians. Even though it doesn't look like all those radians we've been working with, you can have 2 radians, right? Remember, 2 radians would be taking your radius twice around that arc. Okay? So, here's my question to you. How are you going to type cosecant of 2 in the calculator? 1 divided by what, I'm sorry? Very good. I agree with you. Let's go back to the previous, you don't have to turn, but remember how I told you that it's a cosecant? Cosecant is the same thing as 1 over y, which is the same thing as what? So what if I rewrite this as 1 over sine of 2? At that point, can you now plug it in? You sure can. So alpha y equals 1. I'm still in radians, so I'm good. 1 over sine of 2. Hit enter, and approximately 1.010. Cool? Figure out the rest, please. Figure out the rest with your calculator. Alright, if you're watching this video, please check your answers. And then we have one more thing to go over, and then I'm going to show you some tricks on how to memorize the unit circle. Okay? So we're okay with that? Alright, very last thing that I got for you today. It has to do, the questions look exactly the same. But what if I ask you something like this? Find the sine of 9 pi over 3. At that point, you're going to be like, well, I don't remember that being on my unit circle, so I'm just going to use a calculator. But I'm going to tell you, well, that would be on the non-calculator part, because you can solve it without a calculator. Well, first of all, does this reduce?
Yes.
So I can rewrite this as what? Oh, sine of 3 pi. Agreed? And at that point, you're like, well, that's still not on my unit circle. And then I will say, well, technically it is, because the unit circle doesn't have an end. The unit circle can continue to rotate forever and ever, just like we did with degrees. So if we use our unit circle, here's what we know. I'm just going to draw a sketch, and I like to do this for these types of problems. You don't have to do it, but I like to do it just so that I'm like 100% sure what I'm doing. I know that 2 pi is 1 revolution. Therefore, 3 pi would be right here. I like to draw that for myself because then I know that it is coterminal with pi. And then by now, I'm going to assume you have it memorized, or whatever, you have it next to you. You know that the coordinates for pi is -1, 0. Therefore, the sign would be, cool? Alright, let's try another one. What is the cosine of, let's try 13 pi over 6. 13 pi over 6. Okay. So if you like to use the strategy that I use, I like to draw this myself. Now, this time I'm not as comfortable because notice how this was in terms of like just whole pi or whatever. This time we're not, so I like to manipulate the unit circle to my advantage. So because this is in terms of 6, I'm going to turn my unit circle in terms of 6. Here's what I mean by that. This would be 0, and this is typically pi over 2. Agreed? But if I turn it into terms of 6, what if I say 3 pi over 6? Would that be the same thing as saying pi over 2? Yes? And then pi would then become 6 pi over 6. And then 3 pi over 2 would become what? 9 pi over 6. And then 2 pi would then become 12 pi over 6. Well, why would I do that? Because now at this point I know where to start, and I go, okay, well, that's 12, right? And if I need to reach to 13, that means I need to go another pi over 6. Agreed? At that point, now you know that you are coterminal with pi over 6. Agreed? And you know that the coordinates at pi over 6 is square root of 3 over 2, comma 1/2. So now you can tell me that the cosine is what? Square root of 3 over 2. Yes? So technically I can have all kinds of revolutions in here, but you can still answer the question. The hint that you're going to take on whether you know if this is going to be on the unit circle or not, notice how your unit circle has denominators of 3, 4, 6. That's going to be your hint. Okay? I'll give you 2 to try on your own, and that's all I got for you today. Okay? So find the cosine of -7 pi over 2. And then find the tangent of -120 degrees. Okay? Find the cosine of -7 pi over 2 and find the tangent of -120 degrees. Let's talk about them to make sure we all understand. For -7 pi over 2, what I did is I rewrote the unit circle with denominators of 2. So I know that since I'm going in the negative direction, I know that this is -pi over 2, this is -2 pi over 2, -3 pi over 2, -4 pi over 2. Agreed? Sorry. Then all I did was my rotations. So if I'm starting here, then I go an entire rotation. That's 4, 5, 6, 7. So at negative 7 pi over 2, I'm technically at coterminal with pi over 2, which has the coordinates of 0, 1, which means that the cosine is 0. Degrees tend to be a little easier in my opinion, because I know that 120 has to be in between these two, right? But it's got to be closer to the 90, so that makes it coterminal with what other angle? 240. Great, which gives you negative 1/2 and the negative root 3 over 2. And then to find the tangent, I did sine over cosine, reduce, and I got square root of 3. Questions about trigonometric ratios and the unit circle? If you're watching the video, please watch the other video that shows you a trick on how to memorize the unit circle.